Good morning, myself Sahil Braid, and we are Team Hat Overflow. Today we will be presenting AudiHealth, an innovative system that addresses voice pathology detection and enhances voter health awareness. Let's start with why AudiHealth is crucial in India. In India, over 7.5 million people suffer from voice related disorders. That's one in every 63 individuals. This is especially common in voice engaging professions like teachers or commentators. The general consensus in India is that if someone has some voice related issues, they would just drink some water and will think that everything is fine. But later on, this problem can lead to even more serious issues like laryngeal cancer. What Audi Health does is it provides a non invasive method for early detection of any voice related problems. Currently, there are other methods for detecting any problems like electrothlotography or EGG. What they do is they basically put a device fitted with a small camera inside your throat and measures any ventral fold movement. But this method is very expensive, so it's generally very rare. Now, coming on to the methodology. So, our proposed methodology will take in voice of someone emitting a vowel sound like A or E, and then our model will extract features from the audio. For feature extraction, we have used VGG features, which was developed by Google. What it does is it creates a 128-bit embeddings of various audio features like jitter or shimmer. This is then passed to our model, which is liquid state machines, which we have hard coded ourselves, and it consists of different bidirectional LSTM layers. For dataset, we have used Saarbrücken Voice Database, which is a German database consisting of two disorders, ventral polyp and laryngitis, along with healthy voice samples. Coming on to the challenges faced, we had data imbalance between different classes. We had around 250 healthy samples, 256 laryngitis samples, and 76 ventral polyp samples. So, to mitigate this imbalance, we used a technique called SMOT, which is synthetic minority oversampling technique, to generate synthetic data of ventral polyp. For tech stack, we have used Python for building our machine learning model. We have used Flask for integrating the model with the front end. We have used Figma for designing the UI, and then we have used React for creating the website. This is the UI of our project, which we will see later on while showing the demonstration. Coming on to the results, we have achieved an amazing accuracy of 97% on testing data. We have also visited various hospitals like Diva Patil Hospital and Terna Hospital to validate the results, and we tested it on 100 patients suffering from vocal disorders, and our model correctly predicted on 94 patients. This is this is our confusion matrix. As you can see, it has very less false negatives, which means it will never say that you don't have any disorder, even though he or she might be suffering from a disorder. Now coming on to the demonstration. This is the voice sample of one of our team members. Now, as you can see, this has correctly predicted that the voice is healthy. Along with this, we have also plotted a MEL spectrogram where we have frequency on y-axis and time on x-axis, and different colors of bands represent different levels of voice intensity in decibels. This is something which can be easily interpreted by any doctor. So even if the model fails to predict correctly, the doctor can identify any problem. As you can see, for the healthy voice, the voice bands are pretty straight. There are no jitter or vibration in the voice. Now onto the second voice sample. This is a voice sample which we have collected from Devi Patil Hospital from a patient suffering from ventral polyp. As you can see, our model has predicted that the patient has an 89% risk of having ventral polyp. And also in the MEL spectrogram, you can see the voice bands are not straight. There is a lot of jitter and vibrations in the vocal cords, which is caused by the presence of a nodule in the vocal cord. Now, this is another voice sample which we have collected. Uh, as you can see, our model has predicted that he has an 99% risk of having laryngitis, and also from the Mel spectrogram, we can identify that the voice bands are very thick in this case, which means that there is a lot of echo in the voice. Thank you.